Every single day, oil refineries around the world process over 100 million barrels of crude oil. That's roughly 4.2 billion gallons of one of the most flammable substances on Earth, heated to extreme temperatures, pressurized, and chemically transformed inside facilities the size of small cities. A single catastrophic failure at a major refinery could trigger explosions exceeding $12 billion in damages, claim hundreds of lives, and shut down fuel supplies to entire regions for months. Yet somehow, these chemical juggernauts operate 24/7 with remarkable safety. So how exactly do oil refineries prevent disasters of this magnitude? What invisible systems and technologies stand between normal operations and absolute catastrophe? Stay with me, because what you're about to discover will change how you see these industrial giants forever. Oil refineries are essentially giant chemistry sets operating at industrial scale. They take crude oil, a thick, toxic mixture of hundreds of different hydrocarbon compounds, and crack it apart using heat, pressure, and catalysts to create gasoline, diesel, jet fuel, and countless other products. But this process isn't just complex, it's inherently dangerous. The temperatures inside distillation towers can exceed 750 degrees Fahrenheit. Catalytic crackers operate under pressures reaching 500 pounds per square inch. And everywhere you look, there are flammable liquids, combustible gases, and reactive chemicals flowing through miles of interconnected pipework. One wrong move, one system failure, one overlooked warning sign, and the consequences can be devastating. History has shown us what happens when things go wrong. In 2005, a hydrocarbon vapor cloud ignited at the BP Texas City refinery, killing 15 workers and injuring over 180 others. The explosion was so powerful it damaged buildings a quarter-mile away. The total cost, including legal settlements, cleanup, and lost production, exceeded $2 billion in 2012. A fire at the Chevron Richmond refinery in California sent a massive plume of toxic smoke over the surrounding community, sending 15,000 people to hospitals with respiratory problems. The incident cost Chevron over $2 billion and highlighted just how vulnerable these facilities are to cascading failures. And in 2019, a fire at the Philadelphia Energy Solutions refinery triggered a series of explosions that launched a projectile tank weighing several tons over 2,000 feet through the air. The refinery never reopened, costing 1,000 workers their jobs and eliminating 25% of the East Coast's gasoline supply overnight. These aren't freak accidents, they're warnings. And the refining industry has learned from every single one. Today's refineries employ layer upon layer of safety systems, each designed to catch problems before they spiral out of control. The first line of defense? Pressure relief systems. Inside a refinery, pressure is everything. Too much, and pipes rupture, tanks explode, and deadly gases escape. Every pressurized vessel, from distillation columns to catalytic reactors, is equipped with pressure relief valves. These devices are precisely calibrated to open automatically when internal pressure exceeds safe limits, venting excess gases into a controlled flare system where they're safely burned off. You've probably seen these flares, the tall stacks at refineries with flames dancing at the top. They're not waste, they're insurance when something goes wrong. When a reaction runs too hot or a valve fails, those flares catch the overflow and burn it away before it can accumulate into an explosive cloud. But pressure isn't the only threat. Temperature is just as critical. Refineries use thousands of heat exchangers, furnaces, and reactors, each maintaining precise temperature ranges. If temperatures spike too high, chemical reactions can run away, creating pressure surges, toxic gases, or even fires inside the equipment itself. To prevent this, every critical piece of equipment is monitored by temperature sensors linked to automated control systems. If a furnace runs too hot, the system automatically cuts fuel flow. If a reactor starts overheating, cooling systems activate instantly. And if temperatures continue to rise despite these interventions, emergency shutdown procedures kick in, isolating the problem before it spreads. Then there's the Distributed Control System, or DCS. This is the brain of the modern refinery. Thousands of sensors throughout the facility continuously feed data on temperature, pressure, flow rates, chemical composition, and equipment status into a centralized control room. Operators monitor dozens of screens showing real-time data from every corner of the refinery. But they're not alone. The DCS itself is programmed with safety interlocks, automated rules that prevent dangerous operations from occurring. If a pump is running but a downstream valve is closed, the system won't allow the pump to overpressurize the line. It'll either open the valve automatically or shut the pump down. If gas levels in a processing unit drift outside safe parameters, the DCS can automatically adjust flow rates, activate alarms, or initiate shutdowns without waiting for human intervention. It's like having a guardian angel watching every pipe, every valve, every second of every day, but even the best automated systems need a backup. That's where gas detection systems come in. Refineries are equipped with thousands of gas detectors strategically placed throughout the facility. These sensors continuously sample the air for traces of hydrogen sulfide, methane, benzene, and other toxic or flammable gases, if a leak is detected. Alarms sound immediately. Operators can see exactly where the leak is happening and dispatch response teams within seconds. In critical areas, the detection system is tied directly to automated shutdown systems. If gas concentrations reach dangerous levels, the system can isolate sections of the refinery, stop feed flows, and activate deluge systems, massive sprinkler networks that spray water or foam to suppress vapors and cool equipment. Fire is the most visible and terrifying threat at any refinery, with so much flammable material in one place. A single spark can ignite a catastrophe. That's why refineries invest heavily in fire suppression systems that go far beyond what you'd find in a normal building. Firewater systems maintain massive reservoirs of water, often millions of gallons, stored in dedicated tanks and kept under constant pressure. Hundreds of hydrants, monitors, and foam stations are positioned throughout the facility. In the event of a fire, operators can deploy fire trucks, activate fixed monitors that spray thousands of gallons per minute, or blanket entire areas in fire-retardant foam. Some refineries even have their own private fire brigades, teams of trained firefighters who live on site and drill regularly for every conceivable emergency. Beyond water, many refineries use specialized fire suppression systems tailored to specific hazards, for electrical equipment and control rooms. Clean agent systems like FM200 or CO2 flooding are used. These systems displace oxygen without damaging sensitive electronics. For areas with large quantities of flammable liquids, foam systems create thick blankets that smother flames and prevent reignition. And in confined spaces like tank farms, explosion suppression systems detect the initial pressure wave of a detonation and inject suppressants in milliseconds, stopping the explosion before it fully develops. But what about the human element? Technology can only do so much. The people operating these facilities are just as critical to safety as the equipment itself. That's why modern refineries invest millions in training programs, safety drills, and a culture of accountability. Every worker, from entry-level technicians to senior engineers, undergoes rigorous safety training before ever setting foot in an operational unit. They learn to recognize hazards, respond to alarms, use personal protective equipment, and execute emergency procedures. Regular drills simulate fires, gas leaks, equipment failures, and even full-scale evacuations. These aren't optional exercises, they're rehearsals for scenarios that could save lives. Refineries also use a system called Management of Change, or MOC. This process ensures that any modification to equipment, procedures, or operations is carefully reviewed for potential safety impacts before it's implemented. Want to replace a valve? You need to verify that the new valve can handle the same pressures and temperatures. Want to change a process parameter? You need to assess how that change might affect downstream equipment. MOC prevents well-intentioned modifications from introducing unforeseen risks. Another critical layer is Process Hazard Analysis, or PHA. This involves multidisciplinary teams systematically reviewing every step of every process to identify what could go wrong and what safeguards are in place. They use methodologies like HAZOP, Hazard and Operability Study, to ask what-if questions. What if this valve fails open? What if this pump loses power? What if this reaction runs too fast? For each scenario, They evaluate existing safeguards and recommend additional protections if needed. PHAs are conducted regularly and updated whenever processes change. Then there's mechanical integrity. Refineries are full of equipment that's been running for decades under extreme conditions. Pipes corrode. Valves wear out. Heat exchangers develop leaks. If these aren't caught in time, they can fail catastrophically. That's why refineries follow strict inspection and maintenance schedules. Ultrasonic testing measures pipe wall thickness to detect corrosion before it becomes dangerous. Radiography and magnetic particle inspection find hidden cracks in welds and critical components. Pressure vessels are regularly tested and recertified. Pumps and compressors are torn down, inspected, and rebuilt on scheduled intervals. Nothing is left to chance. Corrosion is a particularly insidious threat. The crude oil and chemicals processed in refineries are often highly corrosive, especially when they contain sulfur compounds, water, or acids. Over time, this can eat away at metal surfaces from the inside out. To combat this, refineries use corrosion monitoring systems that track metal loss in real time. Probes inserted into pipes and vessels measure corrosion rates and predict when equipment will need replacement. Corrosion inhibitors are injected into process streams to slow the attack. And in some cases, more resistant materials like stainless steel or special alloys are used in the most vulnerable areas. Another hidden danger is hydrogen embrittlement in high temperature, high-pressure environments where hydrogen is present. Hydrogen atoms can diffuse into the metal structure of pipes and vessels, making them brittle and prone to sudden fracture. Refineries combat this by carefully selecting materials resistant to hydrogen attack, controlling operating temperatures, and conducting regular inspections using advanced techniques like acoustic emission monitoring, which can detect the sound signatures of developing cracks. Let's talk about storage tanks. Refineries store millions of gallons of crude oil, gasoline, diesel, and other products in massive above-ground tanks. These tanks are potential bombs if not properly managed. Vapors accumulate in the space above the liquid, and if ignited, they can cause catastrophic explosions. To prevent this, many tanks are equipped with floating roofs that sit directly on top of the liquid. Minimizing vapor space, others use inert gas blanketing, filling the vapor space with nitrogen to eliminate oxygen and prevent combustion. Flame arrestors are installed on vents to stop external flames from traveling into the tank, and foam chambers are positioned around the rim, ready to deploy fire-suppressing foam in seconds if a fire breaks out. Tank farms are also equipped with secondary containment, earthen berms or concrete walls surrounding groups of tanks. If a tank ruptures, the containment system holds the spilled liquid and prevents it from spreading across the facility or into the environment. Drainage systems within the containment area route any spills to collection sumps where they can be safely recovered. Electrical safety is another critical concern. Refineries are filled with equipment that generates heat, sparks, and static electricity, all potential ignition sources in an environment rich with flammable vapors. Every piece of electrical equipment in hazardous areas is rated for explosion-proof or intrinsically safe operation. Explosion-proof enclosures are designed to contain any internal explosion and prevent it from igniting external vapors. Intrinsically safe equipment operates at such low energy levels that it cannot produce a spark strong enough to ignite flammable gases. Grounding and bonding systems ensure that static electricity is safely dissipated. Tanker trucks, rail cars, and portable containers are all grounded before any transfer operation begins. Lightning is a natural ignition source that can't be controlled, but it can be managed. Refineries install extensive lightning protection systems, tall masts and grounded conductors that provide a safe path for lightning strikes to reach the ground without passing through critical equipment. The tallest structures, like distillation towers and flare stacks, are equipped with lightning rods and grounding networks to protect against direct strikes. Now let's talk about one of the most sophisticated safety systems, the Emergency Shutdown System, or ESD. This is the refinery's last line of defense. If all other safeguards fail, the ESD can isolate and shut down entire processing units or even the entire refinery within minutes. Strategically placed shutdown buttons, both in the control room and at key locations throughout the facility, allow operators to trigger an ESD manually, but the system can also activate automatically in response to critical alarms, such as high gas concentrations, loss of power, Or catastrophic equipment failure. When an ESD is triggered, automated valves slam shut, isolating sections of the refinery, pumps and compressors stop. Feed flows are cut, flares activate to handle the sudden release of gases, and equipment is safely depressurized and cooled. It's a controlled crash designed to minimize damage and protect lives. Refineries also conduct regular safety audits and inspections, both internal and external. Government agencies like OSHA, the Occupational Safety and Health Administration, and the EPA, the Environmental Protection Agency, conduct inspections to ensure compliance with safety and environmental regulations. Third-party auditors evaluate safety management systems, equipment integrity, and operational practices. Insurance companies send their own inspectors to assess risk, and refineries themselves perform internal audits, looking for gaps and areas for improvement. These layers of oversight create accountability and ensure that safety remains a top priority. But even with all these systems in place, the industry knows that complacency is the enemy. That's why leading refineries embrace a concept called process safety culture. This goes beyond rules and equipment. It's about creating an environment where every worker, from the newest hire to the CEO, feels responsible for safety and empowered to speak up when something doesn't look right. Anonymous reporting systems allow workers to flag potential hazards without fear of retaliation. Near-miss reporting encourages people to share close calls so lessons can be learned before an actual incident occurs. Safety performance metrics are tracked and shared openly, and leadership demonstrates commitment by investing in safety improvements, even when they're expensive. One powerful tool in this culture is the Stop Work Authority. This policy gives any worker the right and the responsibility to stop work if they believe it's unsafe, without needing permission from a supervisor. It's a recognition that the people closest to the work often see risks that others might miss, and it sends a clear message that safety is more important than production. The industry also learns from incidents worldwide through organizations like the American Petroleum Institute and the Center for Chemical Process Safety. When an accident happens anywhere in the world, detailed investigations are conducted, root causes are identified, and lessons learned are shared across the industry. This collective learning helps prevent the same mistakes from being repeated. Technology continues to evolve, making refineries even safer. Drones equipped with cameras and gas sensors can inspect hard-to-reach areas without putting workers at risk. Advanced analytics and artificial intelligence are being used to predict equipment failures before they happen. Analyzing patterns in temperature, vibration, and pressure data to spot early warning signs, digital twins, virtual replicas of physical assets, allow engineers to simulate scenarios and test safety improvements without risking actual equipment. And wearable technology, like smart helmets and gas-detecting badges, provides real-time monitoring of worker safety and environmental conditions. So when you add it all up, pressure relief systems, automated controls, gas detection, fire suppression, rigorous training, mechanical integrity, process hazard analysis, emergency shutdown systems, and a culture that prioritizes safety above all else, you have a multi-layered defense system designed to catch every possible failure before it becomes a catastrophe. No single system is perfect, but together they create redundancy and resilience if one layer fails. Another catches the problem. It's called defense in depth. And it's the reason that despite processing billions of gallons of flammable materials every day, major refinery disasters remain rare. But the stakes are enormous. A $12 billion explosion isn't just a financial disaster. It's lives lost, communities devastated, environmental damage that can last for generations, and disruptions to fuel supplies that ripple across entire economies. That's why refineries invest hundreds of millions of dollars in safety systems and why regulations demand the highest standards. The cost of prevention is always less than the cost of catastrophe. The next time you pass by a refinery, those towering columns, endless pipes, and flickering flares, remember what's really happening inside. It's not just chemistry. It's a constant battle against chaos. A high-stakes operation where engineering, technology, and human vigilance work together to keep disasters at bay. And every day that a refinery runs safely, it's a testament to the thousands of people and the countless systems working invisibly to protect us all. If you found this fascinating, drop a like, share it with your friends, and leave a comment telling us where you're watching from. Subscribe and turn on notifications so you never miss a new upload. Thanks for watching. We'll see you in the next one.